algebraic proofs. After watching this video, I will be able to apply the properties of equality to write geometric proofs. So one of the more challenging parts of proofs is there's a lot of reasons why we would do something to manipulate either our equation or to understand key information. So what I suggest is that we use a reasons for proofs document when trying to complete a proof. Now note, this document will be updated as we learn new reasons throughout the year, so I wouldn't suggest to print it as you might have an out-of-date document. So if you click on the link in the notes page, you will see a reasons for proof document. Your document will look something similar where I have all the reasons that I would use in the proof part listed along with an explanation of what that reason might mean and an abbreviation if you're writing this down so that you don't actually have to write the words. Notice how subtract property and substitution property, I would not abbreviate it as sub because those two could be confused between one or the other. Another important concept when trying to do these proofs is the word congruent. So we kind of briefly talked about what congruent means, and it's basically something that has the same measure. So the symbol that we use for congruent is this little equal sign with the squiggly on top and is read is congruent to. Whenever I have tick mark or red slashes on a figure, that also indicates that it's congruent. So I can just assume it's congruent when given a diagram with tick marks like in my example. So equal and congruent are kind of similar, but they're different also. So basically the lengths are equal and segments are congruent. It is correct to say that AB equals CD and AB is congruent to CD. However, it is not correct to say that AB equals CD or that AB is congruent to CD. Notice the difference is when I have an equal, I do not have line segments on top, where when I do have congruent symbol, I do have the line segments on top. So that is the main difference. Another thing to keep in mind is the reflexive, symmetric, and transitive properties that helps us to actually do some of these problems. So reflexive basically means that something is equal to itself. So like AB equals AB or angle A equals angle A. It sounds redundant, but it will be very useful in the near future. Symmetric means that I can basically switch the order when I have an equal sign. So I could say AB equals CD or CD equals AB. It doesn't really matter what side on the equal sign it is. It's basically the same. So I can do that switch. And then transitive is a little tricky. That's when I have two things equal to something that is different. So if I have AB is equal to CD and CD is equal to EF, then AB is also equal to EF. So it's almost like saying because these two things are true, I can basically say that this entire statement is true, and that would be transitive. So now we want to write a geometric proof, which is basically still using the idea of solving equations, but we want to include diagrams such as the image below, or above rather, to our proofs. The first step that you should have is identify your given information and then actually figure out what it means using your picture. So I have that angle FGJ. So FGJ is that red angle is congruent to angle JGK. So those two angles are congruent. So I'm going to do the little tick mark on an angle that says something is congruent to itself. And then I have this other relationship that says angle JGK is also congruent to KGH, to the blue angles. Okay, so then now it's also telling me that the angle FGJ and KGH have expressions that equals those angle measurements. And my end goal is to prove that x equals 6. So the very first reason in a proof that you should always get right is your given information. So if you notice, all of this information was given as the actual problem. So my reason would be given. It was told to me. Now I'm being told that FGJ and equals JGK. And then the same thing, JGK equals KGH. So what happened was I took the given information here that I'm circling in red, and instead of having the congruent symbol, I'm changing it into an equal symbol. Because in order to do algebra, like plugging in equations and solving an equation, I need to have an equal sign. I cannot have a congruent sign. So we are saying, hey, this is still true, but now instead of it being congruent, it is equal. And the thing that lets us change from congruent to equal is called the definition. I'm going to put def of congruent. I'm going to use a symbol. Angles. Okay, so now let's see what we're doing. So now the next statement is telling me that FGJ is equal to KGH, and that was not given to me. But what happened is that these two things, we said that JGK, the angle in the middle, here in green, was congruent to the angle on the left, which is in red, and congruent to the angle on the right. So just like because I have the same thing equal to two different things, then those two other angles also have to be congruent to itself, and that is because of the transitive property. Okay, and now we are actually going to go from all these letters that are very confusing and actually put numbers. So what happened is we have the measurements of FGJ, but up in our given information, we are told that that actually is the same thing as 6x plus 7. And then we also have the measurements of KGH. And again, we are told that that actually the same thing as 8x minus 5. So now, instead of having the letters, I'm going to replace my information so that I have all this algebraic equation. And when I replace something with something it equals, that is called substitution. So now I can solve this regular equation like I would any other equation or the ones before. So I'm going to isolate my variable by adding 5 to both sides. And when you add something to both sides, that would be the addition property. And then I'm going to simplify so that I actually do that 7 plus 5 and that would cancel. So I'm going to write simplify as my next step. Again, I want to isolate my variable, so I want to subtract 6 on both sides. Well, 6x. So I'm going to use the subtraction property. And then again, I'm going to simplify my expression. So then I'm left with 12 equals 2x. Again, isolate your variable. So in order to get x by itself, I will divide. And when you divide on both sides, that is called the division property. And one more time, I'm going to simplify so that I have 6 equals x. Now, we know that 6 equals x is the same thing as x equals 6. However, we actually need to have a statement saying that x is on the left and 6 is on the right, because the end of this proof is whenever we get to the end goal, the prove statement. So what property or what reason can let me switch the order of 6 equals x so that x is on the left and 6 is on the right? Well, that will be the symmetric property. And now our proof is done. I am going to fill out these proofs. I suggest that you pause the video, try and do these proofs, and then see the final answers. You may pause your video now. Okay, so here are the 2 proofs that you should come up with after trying to complete these problems. If you did not get there, it is okay. It takes a little bit each time trying to understand what happened. Be sure to make note of your questions and ask them in class.